Hello everyone, welcome back to the new chapter which is number play, where numbers aren't just used for calculation. In this they become the puzzles which are waiting to be solved. Okay, so in this session we'll explore a lot of things like why even and odd numbers behave in a surprising way, some amazing tricks on divisibility of numbers like 3, 9, 11, which will save you a load of time while solving the questions. We'll talk about digital roots, cryptorhythm. So all these things we are going to talk about. So let's jump right in and start playing with the numbers. So I would say that the first thing, obviously we have talked about this. These are the things which we are going to talk about in this particular session. So first of all, parity rule. To understand this, I can say that, for example, if I'm taking four consecutive numbers, 3, 4, 5, and 6. Now, if I, let's say, place numbers like this, in which there is an addition happening, even if I change the sign in the middle, again, I change the sign. Let's see what are the numbers which are getting generated. This is equal to 18. This is equal to 8. This is equal to 6, right? Now, as you can see, all the numbers which are getting generated through the addition and subtraction which we have done are even numbers. So for a particular set of numbers, doesn't matter, for any set of numbers I'm talking about, doesn't matter, you do addition, you do subtraction, whatever you do, if one of the result is even, then all the other results are going to be even. Same goes for odd. If one of the result is odd, the other set of results will be odd. For example, let's say 3, 4, and 5. I'll 3, 4, 5, 6, and 7. I'll add all of them, right? So this will give me a value of 25. Let's minus 5 minus 6 plus 7, which is equal to 14 minus 11, which is equal to 3. Now, in both the cases, you can see both of them are giving an odd number. So this will always be true. Doesn't matter which sign you place in the middle of two numbers, it is going to produce either even or odd in all the cases. Okay, so this we'll have to remember. Again, on the parity rule, change by even. So basically, switching a sign changes the expression's value by even number, and same goes for odd numbers also. Okay, so if you are switching the signs, the parity is going to remain same, but the absolute value would change. Like we saw that one time it was becoming 18, then it was 8, then it was 4, but it was all even. Okay, building blocks for parities, always remember a few things. When you add odd or subtract two odd numbers, it will always produce odd. If you do the same thing with two even numbers, it will always produce even. When you are doing odd plus minus even, it will produce odd. This is going to be even, my bad. Okay. And even plus minus odd will produce odd itself. So if both are odd or both are even, it will produce an even number. If one is odd and the other is even, it will produce an odd number. Need to remember this. Okay. Then moving on to the next part, again in the same category, which is parity, always even for any integers. As you can see, if twice of something added with twice of something, this is always going to produce an even number. 4 times of something plus 2 times of something, always going to produce an even number. 2 times of something minus 4 times of something, always going to produce an even number. Why? Because this is even, this is even. Addition of two evens is even. Even plus even is even. Even minus even is even. Odd minus odd is even, right? But it is not, they are not going to be even for these. I'm not sure whether they are going to be even or not, but it is not always the case. So for example, these two numbers, I don't know whether they are going to be even or not. Okay, 3 into g. What if the value of g is 2? It is going to be even. What if the value of g is 3? It is going to be odd. So for all these numbers, we cannot define what is the parity of the number. Okay. Now, the next part, which is pairs of 4. Similarly, if I'm talking about pairs of 4, so we just saw the even numbers. Basically, the numbers should be divisible by 2. Now we are talking about the numbers which are divisible by 4 or are multiple of 4. Both are same things. So 4p plus 4q, both are divisible by 4. So the entire number is divisible by 4. We need to check it like this. So if I add these two, 4p plus 4q plus 2 plus 2, that is 4. All of them are divisible by 4. So the entire number is divisible by 4. Same goes for this one, 4p plus 4q plus 2. Divisible by 4, divisible by 4, not divisible by 4. So this entire number is not divisible by 4. This is how you will see whether a number is a multiple of 4, is a multiple of 3, and so on. Okay. Moving on to the divisibility part. So there are a few things that we need to see in this one. So sum and difference rule. Always remember that if we divide a value, so for example, m upon a is possible, m is divisible by a, n is also divisible by a, it is given to you. Then m plus a and m minus a will also be divisible by a. This is what we have talked about, right? Same goes for this. If m is divisible by a and n is divisible by a, then the multiplication of m and n will also be divisible by a and a square. Okay. Third rule, factor rule. If a is divisible by k, then a is divisible by every factor of k. If there is a number, let's say 100, if it is divisible by 25, then 100 will be divisible by all the factors of 25, which are 1, 5, and 25, right? And finally, the LCM rule. If A is divisible by both K and M, then A is also divisible by the LCM of K and M. So let's say I ask you, just give me a number which is divisible by both 4 and 6. There's a number which is divisible by both 4 and 6. Then the number should be a multiple of LCM of 4 and 6, which is equal to 12. So 12 is the least possible number which is divisible by both 4 and 6. Next one, let's try to find out what are the things which are always true, sometimes true, and never true. So again, the same thing which we have talked about in the previous slide. So 8 is divisible by m, 8 is divisible by n, then 8 is dividing m and n. So for example, m is divisible by 8, n is divisible by 8. It means that m plus n is also divisible by 8. Okay. Another thing, if a divides a number, is it also divisible by any multiple of 8 like 24? So we discussed this in the last slide, but the other way around. Let's say 100 is divisible by 25. Then 100 will also be divisible by all the factors of 25. That is true. But 100 will not be divisible by all the multiples of 25. This might be true in some of the cases, like for some of the cases. For example, what are the multiples of 25? 25, 125, 250, 375, 400, 5, 125, and so on. So 100 is divisible by 25, 100 is divisible by 50, it is divisible by 100, but not the rest. Okay, so not always true, not always true for all the numbers. Okay. Odd number plus even number is a multiple of 6. This is something which can never be true because odd plus even is an odd number. Okay. And 6 is an even number. Odd divided by even is not possible. Now, let's try to understand a few shortcuts for divisibility. If you want to check if a number is divisible by 9, just do one thing, a very simple trick. You do the summation of all the digits and see whether the number is divisible by, whether the summation is divisible by 9 or not. For example, let's take a number 7309. Another number 7308. Let's do the summation of the digits. 7 plus 3, 10, plus 0, 10, plus 9, 19. Summation of the digits is 19. In this, 7 plus 3, 10, 0, 10, 18. This is divisible by 9? No. It means that the number is also not divisible by 9. Is this divisible by 9? Yes. It means that the number is also divisible by 9. Same goes for 3. You just see summation of digits should be divisible by 3. So this is not divisible by 3, but this is divisible by 3. So 7309 is divisible by both 3 and 9. 7308 is divisible by 3 and 9. 7309 is not divisible by 3 and 9. Okay, shortcut for divisibility of 11. This is a little tedious. So let me write down the number 328,105, which is there in the example. Calculate the sum of the alternate digits. So for example, this is this. These are the alternate digits. What is the summation? 3 plus 8 plus 0, 11. I take another set of alternate digits. 2 plus 1 plus 5. The summation is 3, 8. Now do the difference of the summation. So 11 minus 8. The subtraction should be in the form of 0, 11, 22, 33, and so on. If it is there, then the number is divisible by 11. Otherwise, it is not divisible by 11. For example, I take a number 358,105. So 3 plus 8, 11 plus 0, 11. There is another set 5 plus 1, 10 plus 5, 11. Since the difference between the two summations is equal to 0, right? So that's why we can say that this number is divisible by 11. As simple as that. Okay. And finally, there is one thing which is the digital roots. What are the digital roots? So digital roots are nothing but you add up the summation, you add up the digits of the number. So for example, if I talk about the number which is given on the screen 489,710, I'll add up 4 plus 8, 12, 12 plus 9, 21, plus 7, 28, plus 1, that is 29. Now again add up the digits. 2 plus 9, 11. Again add up the digits. 1 plus 1, 2. This is the digital root or digital sum. Okay? Digital sum of the number. This is just a terminology that we need to understand. This is the digital sum of this particular number. Okay? And finally, cryptalism. So there are certain, I would say, puzzles in the form of letters and numbers that can be given to you, and you need to find out what can be the value of the letters which can be replaced with the numbers. So for example, uh, this PQ multiplied by 8 is equal to RS. This is given to you. Okay. Now you have to find out what can be the possible values of P, Q, R, S. For example, PQ is a 2-digit number. RS is a 2-digit number, right? Now, multiplication of 8 with a 2-digit number, that should result again in a 2-digit number. Okay. So, for example, if I find out the smallest 2-digit number, which is 10 into 8 is equal to 88. 80. 11 into 8 is equal to 88. 12 into 8 is equal to 96. Now please try and understand this thing, that if I multiply 13 and 8, it is going to become a 3-digit number. Now Let's start with the first one. Let's try to find out what can be the value of P, Q, R, S. 1, 0, this is P and Q, this is R and S. According to the first assumption that we have taken, that P and Q can be 1, 0 and RS can be 8, 0. In that case, the value of Q and value of R will be different, but Q and value of S, sorry. So, but it is not possible. Need to be different. In this, it is same. Value of Q and value of S should be different, right? Since they are different letters. But in the first case, we are getting Q and S to be same, which is not possible. So this is not possible. Now, in the second case, the value of R and S comes out to be same, which is again not possible because R and S are different letters which are used. So this is also not possible. In the third case, I can see that I'm getting a unique value for P, Q, R, and S. So I can say that PQ is equal to 12 and RS is equal to 96. So this is how you solve a cryptariddle. It is basically a puzzle that has been given to you. I think that's a wrap for today's number play session. So today we discovered mathematics without formulas. It is all about founding the patterns in this particular chapter. So if you have entirely watched the video, enjoyed the video, make sure that you keep practicing and remember that like to understand patterns, you have to solve as many patterns as possible. So I'll see you in the next session where we'll solve a lot of interesting questions. Till then, bye bye.